If you want to see someone who doesn't know what they're doing not fix a graphics card, that's what this crap is. This is a Sapphire R9 280X 3GB, which is AMD Radeon. This came in a cheap, untested PC that I bought. I think initially it wasn't displaying anything at all, but after pressing the BIOS button in, there was a picture. Unfortunately, it was this picture with the lines. These lines are artifacts, and artifacts means there's something wrong with the memory. Lines are the easiest ones to spot, but there can be swirls and in a worst case a blank screen. And this could be due to faulty memory, the most common, or the terminal case, a memory controller. Memory controllers are on the actual GPU die, so they're unrepairable. On a side note, the new M1 Max Studio uses the same system. They use their proprietary very expensive SSD that is just memory chips, and its controller is in the CPU. Basically you can't swap out the SSD to repair the memory controller. In Windows 10 there is a picture, but it'll only run under the Microsoft Basic Display driver. If you load the Radeon driver, all you get is a blank screen. On a side note, it's a pain in the ass trying to move the original factory drivers if you use their uninstaller. Basically it leaves remnants behind, so when Windows sees that card again it'll try to load the drivers again. Display driver uninstaller seems to clear everything out so you can go back to the Windows Basic driver. GPU-Z does see its AMD Radeon made by Sapphire, so some info is getting through. As for artifacts, there's a lot more lines in Windows. Back to the memory, we have a problem because we don't know which chip is faulty. Basically there's a lot of chips, so there's going to be a lot of misses if you're just doing it randomly. There is software that can tell you which actual chips are faulty, like mods and mats, but those are leaked internal diagnostic software from NVIDIA. Basically there's nothing for AMD Radeon. Actually I lie, someone did write a script to check the memory on AMD GPUs, and it does seem to work. I found this example of a Russian guy trying to use this in April 2020, and it said this chip is faulty and this one might be faulty. So he changed this chip, but it made absolutely no difference. But when he changed the second chip, it fixed it. But the problem with this method is it's quite hard, convoluted and complicated. There's a bit where you had to go into the BIOS and reduce the clock speed of the chip. This might be a problem, but MV Tech Labs has another method to find bad chips. This is going to sound weird, but he drags down the supply voltage to the chip until it glitches. Then he matches that glitch line on the screen with the normal glitch line that it's putting out. And if the glitch lines are on top of each other, that's the faulty RAM chip. If you look at the back of a graphics card, you can kind of see where the memory modules are. Then it's a matter of finding the power being supplied to it and pulling that voltage down, not to zero like a dead short, but to a lower level with a resistor. He's saying it's this VREF-C over here. And on his card he has a nice test point. As for mine, I'm guessing it's somewhere around here, because similarly it has a lot of parts and vias. If I rotate mine 90 degrees, you can see the areas are practically the same. If we check the voltage of this resistor, we're getting about 1 volt, which I believe is the memory controller. And on this capacitor we get 1.5 volts, which I believe is the correct voltage for GDDR5 memory. To find which one it is, we have to glitch the memory, and you do that by putting a resistor in series with a probe and ground. He recommended 560 ohm, but I used 470, so anything around there will be okay. We touch the resistor, which had 1 volt, and something happens. Artifacts usually persist until you reboot. But we touch the capacitor with 1.5 volts and nothing happens. So the resistor is the one we go for. We check the first chip and our new artifacts don't line up with the fault artifacts, so this is not the one. The second chip also doesn't line up, so that's not it. The third doesn't line up either, so that's not it. Neither does the fourth. It's not the fifth either. The sixth is also wrong. Also not the seventh. It doesn't seem to be the 8th either. We try the 9th and it hits it right on top of our fault. I guess the 9th is the faulty chip, but let's just try the 10th for curiosity. And it sort of hits it on top as well. I guess if changing 9 doesn't fix it, I suppose we'll have to change 10 as well. On a side note, I found some more information in Tech Cemetery's Sapphire RX 580 pulse repair video, where you can work out which is a faulty channel just by the position of the artifacts compared to the Windows logo. His is in the channel A position. Then you reference that to these labeled chip positions. This must be for this specific model, because on mine the artifacts look in the D channel position when it's actually the E channel chips. So I'll leave that up to you. Another bit of info, if you have a blank screen you might not have to go to the Python script, even though Tech Cemetery doesn't explain anything in his long repair videos, so I can't be sure, but it looks like you can plug in a functioning GPU with your faulty GPU. Then you boot up with your good GPU and switch the monitor over to the faulty GPU, and that could display your artifact lines. Now it's a matter of waiting for the chips to arrive and seeing if I can actually solder a BGA chip